The evolution of the universe, from the Big Bang to the present day. The universe encompasses everything we can observe, from the tiniest particles to massive stars and enormous galaxies and galaxy clusters. It even includes the unseen dark matter and dark energy. The scale of the universe is truly mind-boggling and filled with mysteries. Humankind has always sought to understand the origins of the universe, proposing various theories to explain it. Among these, the Big Bang theory is the most widely accepted. According to this theory, the universe began as a hot, infinitely dense point around 13.8 billion years ago. This point exploded, creating matter, energy, space, and time. The early universe went through two major evolutionary phases, the radiation era and the matter era. Initially, after the Big Bang, the universe entered the radiation era, dominated by radiation and lasting for thousands of years. This era consisted of several smaller stages. Planck Epoch, lasting from 0 to y-43 seconds. During this incredibly brief period, the universe existed solely as energy, with the four fundamental forces unified. As the Planck Epoch ended, gravity separated from the other forces. Inflationary Epoch, the universe expanded rapidly during this stage, lasting only 10 to 33 seconds, but increasing in scale by a factor of 1030 during this time. The strong nuclear force separated, and energy began converting into matter, forming a quark-dominated period. Electroweak Epoch. In this stage, electromagnetic and weak forces separated, and protons and neutrons formed. Nucleosynthesis Epoch. After the Big Bang, about 0.01 seconds later, photons, electrons, and neutrinos formed, leading to the fusion of protons and neutrons into light atomic nuclei. This stage marked the end of the radiation era. Following the radiation era, the universe entered the matter era, dominated by matter. This era is divided into three stages. Atomic Epoch. About 300,000 years after the Big Bang, the universe cooled to 3,000 degrees, allowing electrons to attach to atomic nuclei. This process, known as recombination, formed vast amounts of hydrogen and helium atoms, making the universe transparent and allowing photons to travel freely. Stellar Epoch. With the formation of vast amounts of hydrogen and helium, gravity started to condense these atoms into gas clouds. These clouds eventually formed dense spheres, where temperatures and pressures increased until nuclear fusion ignited, creating the universe's first stars. Galactic Epoch. As numerous stars formed, they triggered significant chain reactions, clumping together into smaller clusters. These clusters merged into larger clusters, eventually forming massive galaxies. Over time, stars continuously died and were reborn, and galaxies collided and merged, creating the universe we observe today. This is the evolutionary process of the universe, according to theoretical predictions, and it's the most widely accepted origin hypothesis in the scientific community.